Login accepted.
And now we have the picture. Welcome to Introduction to Apache Pinot. My name is Tim Berglund. I work for a company called StarTree. I run the developer relations team there. And it's my job and my team's job to explain Apache Pinot to the world. Now, Pinot is named after a type of grape, a type of wine. I think that's a great thing. Who doesn't like that? We'll see if there's Pinot at the party tonight. My employment contract requires that I drink only Pinot. I'm not allowed to have Cabernet or Syrah or anything like that until I'm fully vested. It's a weird thing. I didn't expect to see that, but you just kind of play the ball where it lies. Anyway, I think the important metaphor to begin with isn't wine, great as wine is, but textiles. And I guess to back up a step, what I would like to do in the next 49 minutes, actually I have infinite time because my timer is not counting down, so that's good news. We're just here together forever. If there's a button somebody can press that makes that timer count down, I will actually use it to figure out where I am. Okay, here's what we're going to do. I'm going to open up my phone. And out of respect for you, what's that? Yeah, that's not how I do it. Okay. Pinot is an analytics database, okay? So there are a number of things about Pinot that are just not interesting to talk about, like what tables are and what SQL is. I'm not going to tell you those things. But Pinot is a very different and interesting kind of database. The world of analytics is crowded, but there are some new things happening. And a lot of what I want to do here today is help you understand what those new things are and why a product like Pinot exists. I would also like to talk about its architecture, and we'll walk through indexes also. Oddly, that's really where I think the money is in terms of understanding how this thing works, is understanding the indexes. But first, we really need to spend some time on why, because that's a valid question you might be asking. Why is there a new analytics database? It seems like that's a pretty well-covered piece of territory. There's lots of ways to run SQL against giant data sets. Why one more? Well, so textiles. Now, the first clothing that human beings probably wore was animal skins, and this is still a thing. There's still clothing made out of animal skins, right? But after a while, people started to use plant fibers and things like cotton and wool. I guess wool was one of the early plant fibers. These became important ways of making clothing, and we developed ways to spin those fibers into thread and then weave those threads into fabric. And looms are like an old technology. They're not a particularly disruptive thing, but the manual kind of loom has been around for a long time. During this time, though, before industrialization, the limiting factor in the production of textiles was thread. Manual looms are hard to operate, but you could weave things. In effect, one person could weave faster than one person could spin thread. And so the process of thread production was highly distributed, and I guess in computer science we would call that an embarrassingly parallelizable problem, right? You can have lots of people operating a spinning wheel and making thread. And it was a cool thing because this was largely done in the period in which spinning wheels, say in Europe, were in frequent operation. This was largely done by women when they weren't doing the other stuff they had to do to run a household or the way they participated in agriculture or whatever it is, they would spin yarn. And it was cool because after you're doing all of the other sort of manual, more backbreaking things you're going to do, and you're just sitting down, maybe relaxing at the end of the day, talking to friends or family, you can spin. This is a thing you can do with your hands and not think about much. So economically, there's we won't go down this trail too far. But it's kind of an interesting thing economically, where there's this need for this labor-intensive, expensive thing that we need a lot of, and it's easy for people to kind of use their spare time to do it. You didn't have to be a full-time spinner. It was a thing that you could do and extract value out of an hour and a half that you otherwise would have been talking to somebody before you fell asleep at night. Now, making thread was expensive, and when industrialization arrived, we had machines that would spin thread and then machines that would weave, and it was the industrialization of thread production that was the game changer here. Suddenly, a unit of thread became many orders of magnitude cheaper. And it's interesting to ask, when a limiting factor becomes several orders of magnitude cheaper, a limiting factor in some process, what happens with that process? Okay, so maybe as a working class person or a middle class person, and in the medieval period those are slightly anachronistic terms, but you get the idea, a farmer or a merchant or something like that. As a farmer, I can own kind of 2 sets of clothes. Maybe if I'm a merchant, I can own, I don't know, 7 or 8. They're expensive. And now that thread is 10 to the 5, 10 to the 6 times cheaper, am I going to have 1 million changes of clothes? No. All right, if something becomes many orders of magnitude cheaper, you don't necessarily do it many orders of magnitude more times. You find other things to do with textiles. For example, I personally hate charging cables that have the fabric sheathing on them. I like the plastic ones, right? But they're actually hard to get. You kind of have to go to the Apple store and get the Apple ones. Anything you get on Amazon, the Amazon basics, they're all going to have textiles on them. Why textiles on charging cables? What a strange thing. But after, and this, we're just about done with this textile topic, but after thread production and weaving were industrialized, and now things are many orders of magnitude cheaper, you're not wearing 10,000 changes of clothing. You're using textiles for different things. You find different things to do with that newly cheaper thing. The analogy, lest I bury the lead, is a query. So when an OLAP query, some kind of aggregation over a set of things, doesn't take minutes, doesn't take 10 seconds, but maybe takes 40 milliseconds, it's 10 to the 3, 10 to the 4, 10 to the 2, somewhere in there, times cheaper. Do you have 1,000 times as many dashboards? I'm going to go with bad idea. I don't think we need 1,000 times. Maybe there are like 2 or 3 dashboards that you need, but honestly, it's not compute cost that's limiting the number of dashboards you have. It's other things. So when that query becomes that much cheaper, what happens? And that's really, I think, an interesting thing that Pinot is driving. And as we'll see, it's kind of asking us to think differently about how we use the data that's locked up inside the company. A little bit more history, this time more recent history, not textile production, but analytics. Let's just think about this. This is a helpful framing. I've kind of already put these ideas out a little bit, but let me walk through this in just a little bit more carefully. Early 90s, you had what is now the modern ETL tradition, which is now a legacy technology, right? A legacy data warehouse. That was a new idea in the early 90s. Books were being written, consultancies were being formed. It was important innovation. And the people who were on the leading edge of new technology then were driving this thing, and it was mind-blowing. It was focused on creating a printed report in the morning, that a business decision maker could get access to this printed report on 8.5 by 11 or A4 paper. It's funny, I don't know if you go to the United States and you see an 8.5 by 11 sheet of paper, if it looks weird to you. Yeah, right? Okay, that's what A4 looks like to me. Now you feel it. It's fine. It's just, look, why is this kind of skinny? Anyway, this printed page was the goal, and it was a summary of the activity of the business up to the previous day, and that was a game changer, right? It's huge. Important disruptive innovation now seems terribly old-fashioned, but it was a great thing then. Over the years, up until recently, there are a couple things that have changed. Number one, instead of that just going to the top of the org chart, that analytics product is getting pushed down to individual contributors, not people in a fancy corner office, but maybe people on a factory floor or doing whatever it is the business needs as individual contributors, kind of on the front line of the transactional surface of the organization. So analytics are getting pushed from up high in the org chart all the way down low. If you listen to any of the thinkers in the data mesh space, that's a key theme in the data mesh world, is that analytics is pervasive now in the organization and everybody participates inside the organization. Also, that daily cycle time, that batch of daily processing, has remained substantially batch in that legacy ETL tradition, but there's been pressure. We'd like it not to be a day. We'd like it maybe to be an hour. I would like to ask for better than an hour. But there's just been pressure to try to squeeze that shorter and shorter and push it down in the org chart to more and more people. Let me draw a quadrant. This kind of suggests 4 different roles, and I'm going to give you some use cases for what I'm calling user-facing real-time analytics in just a minute that will help flesh these things out. We're going to have analysts, operators, customers, and users. Those are 4 different categories of people. In the old school, the origin of modern ETL, you had analysts, and if we think of the non-functional requirements of the OLAP system, of the analytics system, there are these 3 parameters I'm going to talk about: freshness, concurrency, and latency. All right? How long does it take a transaction that happens in the world to get into my query, to be queryable? That's freshness. How many different people in the company, clients of the system, will be throwing queries at this database at once? That's concurrency. Latency is how long does it take a query to get answered? All right, and recently, the typical sort of dashboard, printed reports became a dashboard, right? So we don't need to worry about the size of the paper. We can all just get along and be friends. Reports moved into the browser a long time ago, so this is a dashboard. The kinds of queries that are going to power what a business decision maker looks at, that same corner office person where analytics started, these are going to be freshness on the order of thousands of seconds. It could take a substantial fraction of an hour or an hour for transactions in the business to get batched up and stuck into my analytics system. That's pretty good for a batch mode system. There could be tens of queries happening against this database at once. It's not super highly concurrent. These are important decision maker people, so it's not like lots and lots of people are throwing queries. And it's okay if these queries take on the order of minutes, hundreds of seconds, minutes to execute. Some of them may. That's not the end of the world. The dashboard's still going to work. Then as you move down the org chart into people who are operating the business, not just making decisions about the business, we see these requirements get a little bit tighter, right? There are more operators than there are analysts. So we're going to have more concurrency, potentially hundreds of users. We would like queries to get done on the order of seconds, right? That would be nice. This kind of describes the current crop of ways of executing SQL against giant piles of data. Spark SQL, Presto, Trino, other solutions like that. They have about these non-functional requirements. And obviously, when the speaker makes a list like this, you're getting to the last thing. That's like the good thing, right? And these are somehow bad and inferior. They're really not bad and inferior. Okay, these are, like I said, these things started as important game-changing technologies, and they've just kind of slowly evolved to deal with problems that we have in increasing scale of data and slightly increasing non-functional requirements. They're not bad solutions at all, and they do great things. They're deployed. They're interesting. I'm just not talking about them today. So if we start to move outside the business, I'll give you an example of what I mean by customer. Uber Eats is U.S. meal delivery service. I never use meal delivery services. I just don't do it. Is Uber Eats a thing here? Yeah? Nice. Okay, good. I had COVID in January, and so I DoorDashed because I didn't want to go out. And wow, that was an expensive hamburger. It's just not a thing I do a lot of, and maybe I should do it more and I'd get used to it. You know, like they say in automation, the things that are painful, do them more often. I don't think that's going to work out for me in this case, though. All right. Uber Eats is an early adopter of Pinot, and restaurant managers are a class of user of this system that get access to analytics. Okay, Pinot is serving queries to restaurant managers. We'll cover this in a minute. But those are people outside the organization. There aren't as many restaurant managers as there are people who like hamburgers, right? So that's what I mean by customers. There's this category of folks outside the organization, not the whole user population, but there are more of them. So potentially thousands of them, maybe tens of thousands, and they are now wanting to look at things in real time. So they're going to need queries. They're going to need a view of what's going on. If you think about what a restaurant manager needs to know about what's happening in the world, it might be difficult to make good decisions based on data that takes minutes to arrive in front of my face or queries that take minutes. I might need to know things quickly. If there's some kind of burst in orders, I might need to respond to that right away. So we have latency requirements that are getting tighter and freshness requirements, again, on the order of seconds. We need that data. We need data that's out there to be here right away. Users are where things get really real. So now we could have millions, tens of millions of people requiring queries to be satisfied, basically sending queries to the database. In the Uber Eats use case, an example would be, I'll just stick with burgers. Had a burger last night. It was great. I'm a fan. Where I live, there's probably like 5 or 6 places that could credibly deliver a burger to me in a reasonable amount of time. It's the fries that are the struggle, right? They just don't, you got to put them in the toaster oven or the air fryer. They're going to be soggy by the time they get to you. But, you know, say 5 or 6 places that are going to get me a burger, and I might be concerned about delivery time. So an example of a user-facing real-time analytics query that I care about is going to be, what's the average delivery time for those 5 restaurants? That's a feature in a user interface that I'm looking at. For me to have a positive experience using that app, it needs to feel like a living thing that's talking to me. Those things need to be updating right away. I do not have 15 seconds for a Spark SQL job to go run and return a result. I need that stuff to be live and refreshing right away. And there's millions of me who want burgers at mealtime, or potentially millions of people in the network. So you see these non-functional requirements as we kind of go counterclockwise around this circle here, or this quadrant. We see the non-functional requirements becoming stricter as we move towards analytics that serve users. And this, broadly, we can just separate this into internal analytics. That's the stuff that we've been doing and have good tools for, and that is a constantly evolving, maturing space, and lots of good products serve that space. I need to be clear. There's not bad. It's just the thing we've been doing. And now there's this idea that that data that's locked up inside the business, we might want to expose that to people outside the business, to the users of the applications that we build, and involve them in the community of decision makers, which is kind of an interesting thing. I mean, we're going to talk about Pinot architecture and indexes and like how we actually can use this thing, but this is showing us an interesting shift. The kind of language we would have been using 30 years ago if we were involved in the ETL revolution and the original data warehouse revolution in the early and mid-90s, is we would have said, there's all this data locked up in the business and it's not available to decision makers. And those decision makers need that data to be exposed to them. And there's all these different little, because relational databases were new, and like everybody was standing up a relational database and building some ugly Visual Basic application that queried it, and it was just, there was all this data everywhere instead of safely locked up in a mainframe. And wow, it's everywhere. It's locked up in these little departmental databases. We need to integrate it, put it in one place, present one report to a decision maker. That idea of data locked up in a business needing to be freed and summarized and so forth, I'm saying that same thing, just pointing at users, right? It's the folks who are using the software that we create who stand to gain if we tell them more about what's going on inside the system. As I've said, we do have technology for this kind of thing, and it's interesting to think about these kind of parameters as you move from the Spark SQL, Presto, BigQuery, Trinos of the world. Those are largely just giving you ANSI SQL. So you can do whatever you want, right? You throw whatever kind of query you want. They're extremely flexible, but latency is high. Spark SQL, nothing takes less than 5 seconds, right? It seems like if it's 1,000 rows, it's 5 seconds. If it's 1 billion rows, it's 7 seconds, which is cool, right? Things are big, they're real fast, but there's a lot of overhead to do simple things in job management and so forth, the way those systems work. Now, as you move kind of towards the lower latency end of things, something like Elasticsearch. There are people who have tried to do user-facing analytics with Elasticsearch with varying degrees of success. It turns out it's certainly faster. You're going to get results faster, but you don't have SQL anymore, right? You're going to get collections of documents back, and if you need to compute aggregates, well, here's your documents. You know how to add numbers, just compute them. So that's sort of that infrastructure work is pushed into the application layer with the wrong choice of analytics infrastructure. Elastic is good for all kinds of amazing things. It's just not. It's not an analytics database. And there are cases, other cases in which people have done this with key value stores. Pinot originated at LinkedIn a few years ago, and the system that no, it wasn't a key value store. It was a document. It was a document store. I retract that. I was just about to say they had built it with a key value store. They built it with a document store. And it was a bad experience, right? They had to build something else. But if you're going to do this kind of thing with a key value store, you can get the latencies. Remember, we have these really tight latency requirements on the order of tens of milliseconds for user-facing analytics. You can get that out of a key value store. But again, that key value store is not going to help you with aggregations, for example. You will be pre-computing every single aggregation that you ever need to get. And there are narrow circumstances in which that makes sense, but they are narrow. And if you want to be doing anything like ad hoc queries against a database, a key value store is not a database. It's a storage layer upon which you might build a database. And if you are interested in user-facing analytics, you're probably not a database developer. You're probably an application developer, and you should spend your time building features that serve users in the application and not using the wrong kind of infrastructure. So, there were dots that I forgot to click through. What else? Just look at a few use cases real quick. It started with who viewed my profile. This was a thing that LinkedIn built. I don't know if you remember LinkedIn years ago. You didn't. Okay. Before I even say that, question. Who uses LinkedIn? Hands, please. Yes, lots. Daily. Am I that way? Okay, all right. I just look for stuff there. I don't know. What's going on with my colleagues? Maybe I'm too social. I don't know. In its early days, it was basically a site where you could store your resume and your contact list. And why you would visit such a site more often than once a month is beyond me. And frankly, was beyond me, because I didn't back then. It wasn't interesting to do. And then they really started adding social media features like a news feed and things to try to create more engagement. But it was this who viewed my profile that was some stroke of genius on the part of some product manager that is just sticky for certain kinds of people, all right? And I'm the kind of person who really likes to get in front of big groups of people. Like, this is very fun for me. So it stands to reason that I'd probably also be interested, just the kind of person who is looking at my profile, And that's more of us than we might like to admit. But it was a feature that they created just to get people to come back to the site more, to make it something more interactive. And for it to be real time, they had to build new infrastructure, and it was for this reason that Apache Pinot was born. This was the feature that drove the work inside LinkedIn that led to Pinot. even just the feed now, the Pinot deciding what articles to show you, I don't know if that's based on some kind of like nefarious political mind control thing. We'll never know, right? Probably not in the case of LinkedIn, but it is considering what articles have you just seen, who has just interacted with something you posted. All of these real-time things that are happening, that are events coming into Kafka topics, those are getting consumed into a Pinot cluster. And to figure out what to display on your feed, you're loading a page, there's a Pinot query being satisfied. So the most elemental things on LinkedIn are driven by Pinot. And the easy stuff, this is kind of an obvious one, but like how many people have viewed a post? I'm not going to ask for hands of how many of you go back and check how many people have viewed your post after you post something on LinkedIn, because I will tell on myself in two ways. Number one, that I post content on LinkedIn. Two, that I do that. And I might be the only person in the room. I don't know. I don't want to know. But that's another example of a pretty obvious aggregation being done by this database, and it's all being done in real time. We talked about Uber Eats a little bit, so there's this restaurant manager interface. That is that customer quadrant. So there are thousands of these people, or maybe tens of thousands of these people, who need to see what's going on with their restaurant right now. And during rush periods, that actually is a real-time problem. They need to know that. They need freshness on the order of seconds, and they need displays that are live. And of course, the users of a meal delivery app like Uber Eats also need that stuff to be live and updated right away. If I've got delivery dates or delivery times from 15 minutes ago, I could make a bad decision if it's 6:15, right? Because that could be rush time, and my fries could be very soggy and beyond the reach of my toaster oven, and that would not be good. There are a few other recent tidbit, like all of the global meal delivery apps. So the folks who dominate in Europe and parts of Asia and the Americas, all of the meal delivery apps are becoming Pinot users. So this is a thing, like if you're hungry, Pinot will feed you. I would not ever quote me on that, actually. I regret saying those words. But this is a use case that just makes a lot of sense. Super cool community, there's logos. They're important. There's a great Slack workspace. Lots of people use it. Data model. I don't have a slide. I just have a section title here because I'm not going to tell you what tables are. That's all. They're just tables, and they're the tables that you know. And the data types are kind of the usual suspects. The query language, I'm not going to tell you about SQL. I'm not going to show you examples of SQL. Dang it, it's SQL. It's a subset, right? Joins in the current version of Pinot 0.10 are limited. There are special kinds of tables that you can make that are basically reference data tables, and you can join to them, but you can't do arbitrary joins from table to table. That will be changing in the near future, and joins are always a pain, right? So this whole tough guy, queries should take 50 milliseconds, we're real time, seconds is too slow and all that. Well, then we're going to build joins, and we'll see about that 50 milliseconds, won't we? So, those joins are an expensive thing because you have to get things from multiple places and ship them around, and they're just hard no matter what if you've got denormalized data. So that's coming as a feature, but the current SQL implementation is not a complete ANSI SQL. It's a significant subset. The architecture, I think, is pretty interesting, and I'd like to talk through it. I really think, honestly, when you're being introduced to Pinot, I'm trying to give you three things. Why? We just did that. How is it built? We're about to do that. And what's up with the indexes? And the indexes seem awfully specific of a thing, kind of like a deep divey sort of thing for an intro to Pinot talk. But again, I just am of the opinion that that's where the money is in a database. Like, you need an architecture that can support your non-functional requirements that you've set out to satisfy, but indexes are where the innovation happens. Interesting ways to read the data is just where things shake out if you can ingest well. All right, let's go with batch ingestion of data first. That is not the only way to ingest data in Pinot, but let's start with something simple. let's say I have a bunch of JSON. These are clicks. This looks like clickstream data. So we're going to ingest that into a table, which seems reasonable, right? I'm going to create a table. It's going to have a schema, and there'll be some other sort of options that I set on that table. And I will set up a command line tool that will import from my JSON. In this case, I'm drawing JSON on the screen. It could be CSV, it could be Avro files. Excuse me, there are command line tools that I just point at a directory full of these files. I give it a little schema config, and that itself is a JSON file. Press the button, and the data gets sucked into the table. And it's actually stored in Pinot in things called segments. So I'm just going to show these segments as numbered things. A segment is a file that can fit on a disk. So it's going to be stored on a disk, on a machine somewhere, and can be reasonably memory mapped by a process. So internally, these things are memory mapped. So that just kind of sets some bounds on how big a segment is. And when you're doing importing or when you're configuring a table, you get to set rules for when Pinot decides to create segments. But they're generally manageable in size kinds of things. So there you go. We have this command line tool. We point it at our data. We say, please ingest it. And that tool creates segments and puts them somewhere. Hold that thought. Those segments need to live somewhere. They're going to live on servers. And actually, that's actually what the Pinot component is called, that segments. They're actually called servers. I'm still upset about this, but we'll come back to that. Let's talk about the structure of a segment, because there are some insights here that are important and that are decisions made because of the kind of database Pinot is. Now, we're importing all of these rows. That's just going to be a row, except we don't store that as a row. All right, I do not take that JSON and serialize it as some kind of byte structure and plop it into my segment file. What I do is I store it by columns. So I'm going to take all of the values. So I'd say I've got 1 million of these clicks that I'm importing into this segment. I'm going to take all million IPs and serialize them in one shot, beginning at this byte offset and ending at this byte offset in the segment. Then I'm going to go do the same thing with user ID. And then, I need an index for user ID. So I've created an index. I'm going to create that index and serialize that. The on-disk representation of that index data structure is going to go there into the segment. And let's see, all my remote user values, all my time values. I didn't make an index for time. I did make a time index. Oh, that's good. Because there's an actual time range or timestamp index type. So I can index my time field in case I want that. Got that other time thing. That's kind of weird. Request. Notice these are not all the same size. And that's because Pinot compresses. It's a columnar database. It's storing data in contiguous runs of column data. And certain kinds of fields are going to compress well. Like it'll make, this is request. Yeah, there are probably 3 of those that are going to show up, or 4 at most, right? There's not a whole lot of cardinality in request. So it'll use a dictionary and compress those. It's not going to store GET over and over again, or POST. It'll store a byte that points to a dictionary. It also, just incidentally, will do, there are various lossless compression things that'll happen with the column data. So it's trying to be parsimonious with disk space. Looks like we didn't index request. That makes sense to me. Bytes, who cares? Oh, we do care. We made an index on bytes. Referrer, again, referrer is probably going to be pretty low cardinality. Agent, not as low as we'd like it to be. And then there's this other cool kind of index called a star tree index, which we'll talk about a little bit more in a minute. That is the most magical index in Pinot that does some cool things. But it's a way of taking several fields and basically, like if you ever make a pivot table in Excel or Google Sheets? No? Okay, some yes, some no. Kind of telling on myself as a little bit of a manager that I would do that. But sometimes you have to, right? It's where you take several dimensions, and for all the unique combinations of those values, you run an aggregation. So like, what's the average? We'd need some kind of like time on the page or some kind of measurement. What's the average measurement given a particular referrer, agent, and status? And that star tree index stores that on disk, like saving a pivot table to disk. So you have log n access to that combination of those 3 parameters, and the aggregate you want is already there, already pre-computed. So you don't have to go, read in all those values from the column, do all kinds of strange filtering, and run the aggregation. In CPU, you just have it built for you. So it's a cool index. All right, so this is a segment, and of course we're going to write lots of these, and they're all going to be slightly different. Basically the same thing, but not all the lengths will be the same. So yeah, we'll just call those segments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And those get stored on, I am not making this up, a server. That is the name of the component in Pinot that stores the segments. We did come up with that ourselves. Workshopped it a lot, polled well, Servers scale, right? We'll have multiple servers and lots of segments. We'll have as many servers as we like. This is how we scale compute. It's also how we scale storage. It's how we scale storage. It's also how we scale compute. We'll see that in a minute. Trivially, there's replication, right? So segment 1 is going to be on more than one server. Segment 2, segment 3, they're all going to be, there'll be multiple copies of each segment. Segments are immutable once written. That's the cool thing about them. So it's not like we need an odd number of replicas to get a consensus about values that could be out of sync. There's just none of that. Once the segment is created, that segment is itself forever until it's expired, until it's outlived its life. Okay, so these servers are the component in Pinot, starting to put some architectural components on the page now, where segments are stored. Also, they do the actual processing of queries. So queries get shipped to servers, and the compute gets done there. They're going to be reading things out of segment files, doing filtering, doing sorting, doing whatever it is, running aggregate functions over the filtered and potentially sorted results. They'll be doing, for what joins are currently supported, they'll be doing that joining locally on a server. Potentially a query might need to access many segments, right? So if I'm server 2 and somebody's asking for data that's in segments 2 and 7 and 11, I will perform that query on those segments, sort of locally scatter to those segments and gather the results back together. So a server does that. Servers are pretty busy. Now, segments, as I say, they are the real heroes of Pinot. They're the ones doing the actual work. They never talk to the clients, but they do the hard work. Sound familiar? Segments can be put in the cloud. There's this thing that we have called deep storage. Basically, just think of that as S3 or Azure Blob Store or whatever. We can spool old segments off into that, and if a server suddenly needs one of those old segments, it will load it from the cloud. This will be a high latency query, so your P99 will be maybe a little bit off. It'll bring this, gigabytes file from S3 into the server, but it handles that automatically. Okay, we have some more components. Brokers. And so I have now a query that a client throws at a broker, and the broker is going to know that that query needs, say, segments 2 and 8. And it's going to figure out some servers that have segments 2 and 8. And right now it sees server 2 and 3. It can get its work done with just those. In fact, it could just send that query to server 3. And that would be, if you only needed 2 and 8, you could get that done with just server 3. There we are. Here's the whole system. There's also a unit or a component in the system called the controller. We'll talk about that a little bit more in a minute. It talks to Zookeeper. Clients talk directly to brokers. So you send a query to the broker figures out what servers need to be talked to, servers do the work, send the results back, brokers do gather results. They have a little bit of work to do, so they will, having scattered, they will gather and send results back to the client. And remember, there is ingest happening all the time, right? Ingest can just be going whenever. Internally, Pinot uses Apache Helix for cluster management. That's like, it knows it needs so many servers and so many brokers and things need to be in such and such a way. Helix just helps keep the cluster, the components of the cluster running. It caches metadata, and it's where you go to talk, it's the box you talk to change schemas, create tables, upload segments, and do things like that. Somebody should ask, what about streaming data? I'm talking about batch upload. I literally said a command line tool. I didn't see anybody walk out of the room when I said that. A little disappointed. Somebody should have at least yelled, right? Well, this is batch ingest into what I'll now call an offline table, okay? And that happens, and segments are just created in that table. They're stored on servers, and that's great. But what about when it's streaming data, which, frankly, it usually is. That's why Pinot is interesting, because it can connect directly to Kafka, therefore directly to Pulsar, and ingest data in real time. So what happens here is there's this new special thing called the consuming segment, all right? And that fills up. As it fills up, it creates one of these traditional segments that we've been talking about, and just keeps doing that for as long as you've got data streaming in. And of course, we'll set an expiration time on those old segments. We don't want to keep them forever necessarily. But that consuming segment is queryable. So when you query a real-time table, you're querying the offline segment files and that consuming segment as well. So as soon as data is ingested into Pinot, it is instantly queryable. So the event happens in Kafka. Pinot consumes the event. It uses its own consumer. It's not using Kafka Connect. And you're querying that data right away because of this mechanism. Let's talk briefly about indexes. What kinds are there? Forward index. That basically is just a, here's the primary key of the row. Give me the row. That's like, here's document ID. Give me the thing. That's cool. It's good to have. Inverted. This is like a text index kind of thing. It's a simplified term search. So we'll tokenize the values in a field value and be able to find rows that contain one of those values. Bloom filter. There's a Bloom filter index. This is a way of knowing, is a given value definitely not here or probably here, if you know how Bloom filters work. It's like a very space-efficient bitmap index, you could think of it as. There's an index for doing range queries. There is an embedded Lucene. So anything you can do with Lucene, fuzzy text searches, regular expressions, just good old term search like you do with an inverted index. In a text field, you've got access to all that. There's a geospatial index type. Stands to reason, given that folks like Uber are doing meal delivery and they're very location-sensitive kinds of things. They've contributed the geospatial index. There's a very cool JSON index. You can have arbitrarily nested JSON and performantly query the JSON index. So if you've got some complex piece of JSON, you don't need to denormalize that into columns or flatten it out. Just index the JSON column and you get access to it. There's a timestamp index. I mentioned this super cool star tree thing, which again is like making a pivot table. You've got several dimensions. We'll say, referrer, operating system, and postal code. And then how long did that person spend on the website? So you could compute an average of people in my postal code who use Brave, and I forget what the other dimension was that I said, but whatever it is, you basically just get like tree lookup time access to that aggregation. The benchmarks for this, there's a blog post, a star tree blog post, I think, about the benchmarks for the star tree index. So the name of the company I work for is Star Tree. That is an implementation detail that has leaked into the interface. Most people will never know that. The thing is, it's dangerous to do that with companies, because in a few years from now, the Star Tree index isn't going to be the most mind-blowing cool thing. There'll be other cool things, and we'll be talking about something that isn't just Pinot, but layers on top of Pinot, you know. And we're still called Star Tree. It's still a cool name, right? I think it works. Usually these are dangerous, these leaks, but I think this one works. And that is a super powerful index. And I think Pinot is super pluggable on the inside, and so this list of indexes isn't going to sit still. And I kind of think, given that there's this framework for scaling storage, scaling compute, and doing real-time ingest, and again, perfectly solid batch ingest, if you've got giant piles of data, if you've got a data lake, you know, and you'd like it to be queryable in a reasonable period of time, that's a thing people do with Pinot, right? Just get the data from the data lake into Pinot, if it reasonably fits, depending on the scale of things. So fine, there's batch ingest, there's really good real-time streaming ingest, integration with Kafka, and therefore with Pulsar, and things work well with Kinesis, and so forth. Like, with those basic things in place, here's a scalable database, you can get data into it real fast. How do you want to get data out of it? Well, that's an indexing question. And these being pluggable, like easily pluggable, I think is a key thing. That's a good architectural decision on the part of the folks who are building Pinot, because now innovation can take place here. And I think innovation will need to continue to take place here. That is the thing that my timer is done. And you know what that sound is? That's usually my nap timer. This is my second full day here in Europe. 100% took a nap this morning because I didn't really sleep last night. So it's not a good sound. I don't feel good about that when I hear that. I feel good about being here, though. This has been good. Anyway, that's kind of it. So remember, we've got a different thing people are doing with analytics. Honestly, analytics, to me, has always been kind of a boring thing. Let's make reports, let's make dashboards. Absolutely pivotal and critical. I've never found it super interesting myself, even though there are lots of interesting problems and careers built there. But this new thing is happening where this is a way that we deliver features and applications now. And that's kind of what has gotten my interest. I'm relatively new to this part of the world. And that's what's gotten my interest here, is because that's traditionally, my heart is as an application developer. Now, oh, wait a second, there's things we can do with analytics that serve features directly to users. We can take data locked up inside a system, organization, business, whatever you call it, and make features that are useful, that engage me as a user, as a decision maker, as a person in the community of decision makers in that system. So we can probably build things that make our services more useful by exposing that information to, these relatively good decision makers who are tapping on stuff on the mobile apps we make and clicking on things on our websites. I think that's pretty exciting. It's got an interesting architecture, not too hard to understand, cool set of indexes that's going to keep growing, and I am really interested to see where this thing goes. I'm glad you were here. San Francisco is a ways away from any part of Europe, really. But, if you're there, 16th and 17th of August, you can still get in on this. That QR code will get you to the Summit website, and that discount code will get you 30% off because you're my friend. What an American thing to say. We spent some time in a room, 150 of you and one of me, and we're friends now. But you know what? We are. Thanks a lot for having come.